Hi guys, in this video I'll talk about friction. And friction is a property which basically opposes any relative motion or slipping or sliding between surfaces in contact. So if two surfaces are in contact and they try to move relative to each other, or they slip or they try to slide, then friction will act. Okay, for that the surfaces must be rough. And friction can be of many types. Friction can act between two rigid bodies and we call it a dry friction. There is another types of frictions which acts between solid bodies and liquid viscosity, and between layers of liquid again viscosity. We'll not deal those frictions in this video. So they are different type of frictions. So we'll be talking about only friction between two rigid bodies, and we call it dry friction or simply friction. In this, it can be further classified into two parts. One is static. It acts when there is no sliding, and it's a self-adjusting, and it can adjust its magnitude as well as direction depending on the direction of the applied external force which try to move the object. Okay, so important thing is it acts when there is no sliding. Okay, when there is no slipping, it acts, and when there is slipping, actual slipping takes place, the friction acting is kinetic. It is opposite to the relative motion and it has a constant magnitude which is given by mu k n. Okay, so basically this diagram explains everything whatever I told you. This is the diagram. F external, there is a block, let's say of mass m, which is resting on a rough surface having coefficient of friction mu s and mu k, and an external force applied. Okay, so first thing in the questions of friction you should do is find out the normal reaction. Normal reaction in this case will be nothing but mg, because normal balance is mg. So the maximum possible friction, which is also called limiting friction, will be mu s into n, which is in this case mg. So mu s mg. Okay, so till the moment this external force reaches mu s n, we cannot say, we can say that friction will be equal to the external force applied. For example, if let's say F external is this F1, which is less than mu s n, because this angle is nothing but 45 degrees, so the friction will act equal to F1. If external force is F2, friction will act F2. If external force is increased to mu s n, the friction will act mu s n and the object will not move. And if we further increase the external force, the object will slide, and a constant magnitude friction which is equal to mu k n will start acting. Okay, so and if you further increase the F external, friction will become constant because it is kinetic in nature now. Okay, there are few things on which friction depends. It acts common to the tangential to the common surface. It is independent of the area of contact. This point is very important, and it is proportional to the normal between the surfaces. Mu s is generally greater than or equal to mu k. Generally it is greater than, so we can say the static friction, maximum value of static friction will be more than the kinetic friction. This, okay, this is the maximum value of static friction, this is kinetic friction. Okay, so let us solve few examples in which we have to just find the direction of friction force and if possible the magnitude with the current knowledge we have. F external is applied if, again I'll say case 1, when block is not moving, acceleration of the block is 0. It implies the friction force will act in this direction and friction force completely balances F external. Okay, and if the block moves, if acceleration of the block is not equal to 0, I can say friction force acting will be mu k n. N is the normal, and I can write the equation F minus friction is equal to ma. Okay, in the next example, there is a block resting. If acceleration of the block is 0, I can say the force, just resolve the component of mg. This is mg sin theta and this is mg cos theta. So mg has been resolved. This is normal reaction and this is friction. Okay, so if acceleration is 0, I can say friction balances this force. Friction will be equal to mg sin theta, irrespective of normal reaction. So if acceleration is 0, the friction will be this. If acceleration is down the incline, not equal to 0, I can say mg sin theta is greater than friction, which is in this case will be mu k into n. N is nothing but mg cos theta will give you ma. Okay, in this case, friction on block, let's say block 1, the surface here is let's say smooth and this is rough. So I can say on 1 friction will act in forward direction, and on block 2 the equal amount of friction will act in backward direction. Just listen to my explanation. The whole system is moving towards right and there is only one force on block 1, which is friction, which can move it towards right. So it will provide the acceleration to the block 1. In this case, as the whole system will move towards, this is again smooth and this is rough. So I can say now friction is responsible for taking 2 along 1. So friction will act towards left on 2 and will act towards right on block 1. Okay. In this example, if at equilibrium, the system is at equilibrium, I can say that for 1, this is mg, this is F, so the friction must be acting in upward direction on 1 and this will be the normal. If talking about object 2, I can say friction on 2, friction, this is same friction and this is mg, m2g. So the friction from the wall must be in upward direction on 2. Okay, these two frictions are action reaction pairs. On 1 by 2, on 2 by 1, they must be equal and opposite, and there will be normal reactions n and n dash, both will be equal. So if there is no external force, obviously the friction will be 0, and because in the absence of friction the block has no tendency to move or slip, so it will not act. Okay, enjoy.